Welcome to Study Loop.
So in this reaction, we are given with the reaction of acetic acid with ethanol, which produces ethyl acetate and H2O. We're given the equilibrium constant value for this reaction. We're given the volume of the reaction mixture. We're given the initial concentration for both the reactants, acetic acid and ethanol. And we have to find out the mass of ethyl acetate at the equilibrium. And to do that, what you have to do is first you have to set up an ice table to know the equilibrium concentration for the ethyl acetate. And from there, using the expression for Kc value, we can find out the actual equilibrium concentration for this. And from the equilibrium concentration, using the volume of the reaction, we can find out the number of moles of the ethyl acetate produced, and from there, using the molar mass, we can easily find out the mass of the ethyl acetate in the equilibrium. So the first step here will be to set up an ice table to know the equilibrium concentration. So if we set up the ice table, here we have CH3 COOH, and then we have CH3 CH2OH, and in the product side we will have CH3 COO C2CH3 CH2 CH3, and we will have water. So the initial concentration for both the reactants are given. So for acetic acid it is 0.275 molar. Then for ethanol it is 3.85 molar, and the initial concentration for both the products will be zero, since at the initial stage we do not have any product produced. Then if we consider the change as x, then for both the reactants it will be minus x, and for both the products it will be plus x. Since all the coefficients for the reactants and products are 1, that means we do not need to add any numerical value to the x. And from here we can write down the equilibrium um, concentration for each one. So for acetic acid it will be 0.275 minus x, that's basically initial minus change. And then for ethanol it will be 3.85 minus x, and for both the products, ethyl acetate and water, it will be x and x. So from here we can so now we know the equilibrium concentration for all the components of this reaction. So from here you can set up the equilibrium constant expression. That will be the product concentrations over the reactant concentration. So product here is CH3 COO CH2 CH3, and we have H2O. And in the reactant side we have CH3 COOH and CH3 CH2OH. So now we know the value of Kc, which is given as 6.68. So 6.68 will be equal to, so both the product concentration are x, so we can write x square on the top, and for CCCWH it is 0.275 minus x, and for ethanol it is 3.85 minus x. Now if we just rearrange this equation, we will get a quadratic equation like 5.68 square 5.68 x square minus 27.55 x plus 7.08 equal to 0. So this is a quadratic equation for x, and if we just solve the value for x, we can just use this formula, minus b plus minus root over b square minus 4ac over twice a, where a is this value, b is this one, and c is this one. So if we just solve this, we'll get two values for x. These are 4.56 and 0.272. Now if we plug in these two values, we'll see that if we plug in 4.56 here, we'll get negative concentration for both the reactants. So that means that 4.56 is not an acceptable value for x because we cannot have negative concentrations. That means our valid value for x is 0.272, and from here we can say that, so since we just need the equilibrium concentration for ethyl acetate, so we now know that the equilibrium concentration for ethyl acetate is 0.272 m. Since its equilibrium concentration we assumed as x, so now we know the equilibrium concentration for ethyl acetate. Now from here we can find out the number of moles for ethyl acetate, which will be the concentration times volume, because you know that it's m by m times v, so the concentration is 0.272 molar, or we can write it mole per liter times the volume is given as 15 liter. So from here we will get the number of moles of ethyl acetate, which will give us a value of um, so the number of moles will be 4.08 mole. And then we can just, from here we can easily find out the mass of ethyl acetate, which will be number of moles times the molar mass. Since we know that number of moles equal to mass over molar mass, that means mass will be number of moles times molar mass. So the molar mass of ethyl acetate is 80.11 gram per mole. So from here we will get a value of 359.49 gram, and this is the mass of the ethyl acetate at the equilibrium.